Thanks everyone for joining. We're really excited to kick off LSCE with our first keynote panel. My name's Jenna Van Leeuwen, and I'm the co-lead with Alla for this exciting event. And I'll pass it off to Alla now to go into our opening remarks and to kick off the event.
Thank you, Jenna. So hi, everyone. On behalf of both the Life Sciences Career Development Society and the Canadian Society for Molecular Biosciences, Jenna and I would like to thank you all for joining us today in kickstarting off the Life Sciences Career Expo with our very first plenary session. So in addition to our wonderful keynote panelists, the organizing committee is also very excited to present a great variety of different sessions and activities that are planned for you throughout the duration of the event. As organizers affiliated with the University of Toronto, we wish to acknowledge this land on which the University of Toronto operates. For thousands of years, it has been the traditional land of the Huron-Wendat, the Seneca, and the Mississaugas of the Credit. Today, this meeting place is the home to many Indigenous people from across Turtle Island, and we are grateful to have the opportunity to work on this land. We also wish to acknowledge and are grateful for the traditional Indigenous lands that all of you work and live on, no matter where you are joining us today. Thank you for our moderators, panelists, workshop facilitators, and participating company representatives for making this event happen. We would also like to extend our deepest gratitude to our sponsors, so CIHR, the Temerity Faculty of Medicine's Division of Graduate and Life Sciences Education at the University of Toronto, and the University of Toronto Faculty of Arts and Science. We also like to acknowledge or encourage you to network with other attendees through the community boards and network tables, and would like to remind you to vote for our People's Choice Award for the 3-minute thesis competition, which is open today until 8 p.m. Eastern. Without further ado, I'd like to pass it over to our moderator, Dr. Mamdani, who will introduce our panelists for our exciting first keynote, which is on AI and the future of research, health, and work. And if you have any questions for our panelists, we encourage you to use the Q&A function on Zoom. Thank you.
Great, thank you very much. It's a pleasure to be here. We've got a pretty terrific panel, if I do say so myself. I think we have some very distinguished people, and I think we're going to have a pretty interesting discussion. My name is Mohammed Mamdani. I am the Vice President of Data Science and Advanced Analytics at Unity Health Toronto, which is a compilation of 3 hospital organizations in Toronto, as well as the director of the Temerity Center for Artificial Intelligence Research and Education in Medicine. We just call it TCARM because nobody can remember what it is. So I'm also director of TCARM, which is a center at the University of Toronto that focuses on artificial intelligence in medicine. And I'm also a professor at the University of Toronto in medicine, pharmacy, and public health. And it's a pleasure for me to really talk about something that I'm really passionate about, is this new kind of buzzwordy thing we're calling artificial intelligence. It's been around for a while, and now it's gaining a lot of momentum and traction. We've seen the impacts that it's been able to have on other sectors, like people who go on to Amazon and shop. It's just magical how it just knows what you want to buy next. And you think, how does it do that? And we have all this sort of activity in self-driving cars, and you just have to pick up your cell phone and talk to Siri or Google Assistant, and it magically tells you the answer of practically any question you want to ask it most of the time. How does it do all that? Well, I mean, there's a lot of advancement that's been made in terms of how we store data, how we process data, and how we analyze data to really bring utility out of it. And that's really what artificial intelligence is about. I also think that healthcare, we're still living in the world of faxes. We still do things the old-fashioned way. It's going to hit our industry quite heavily in the future. And I think it's going to have profound implications on how we do things. So let's get right into it. What I'd like to do is first to start off and focus on our esteemed panel. So on our panel, we have Dr. Suneet Das, Dr. Catherine Hume, and Dr. Nabila Chaudhry. And I'd like the panel to spend just a little bit of time talking about you. So if you could just spend just a couple of minutes on 3 things. I've asked the panel to basically, of course, introduce themselves and let us know about what's your main job. Like, what do you actually really do? Because you probably have 20 million things, but what's that one job you do? And then what are the other things that are interesting in terms of affiliations that you want to tell us about? The second thing is your academic journey and career path. How did you end up where you are now? Was it just, I just went with the flow, or it was premeditated? How did you end up here? And the third thing I'd really like us to hear from our panelists is if you had a time machine and you can go back to when you were an undergrad student and you can say, hey, that's me when I was younger. What's the one piece of advice you would give yourself knowing what you know now? So why don't we start with Dr. Sunit Das?
Thanks, Mohammed. Well, good afternoon, everyone. Thank you to the organizers for inviting me to be part of this group. I'm excited to be here and eager for what it is I'm going to learn and hear as well. So I'm Sunit Das. I'm a neurosurgeon at St. Michael's Hospital, which is one of the 3 hospitals that form Unity that Dr. Mandani works at and is one of our leaders at. I'm also a scientist here at St. Michael's and at the Hospital for Sick Kids. My clinical practice is in neuro-oncology. I take care of patients with brain tumors, and much of the surgery that I do is technically quite exciting, and much of the care that I give as a physician is complex and for me, very rewarding. I also am very active as a scientist and have a basic laboratory that is trying to understand the biology of a disease called glioblastoma, which is the most common brain cancer that I see in my patients, and is one that's incurable, for which we don't have treatments that are as adequate as what we would hope to be able to give patients. I had a strange journey to medical school, probably not the typical one. I went to university thinking that I would end up in medicine. It was an interest of mine from the time I was young. And then read the Iliad and was totally thrown off course. And I ended up doing an undergraduate degree in literature and going to grad school in philosophy. And somehow on that journey, ended up back in medicine. I didn't come to medical school to become a surgeon. And this is my failed attempt at becoming a psychiatrist, which I thought was going to be the place for me. In trying to answer Dr. Mamdani's question of how it is that I made these decisions, I can absolutely paint this linear narrative in retrospect that makes sense of how A led to B to C to D for me, and it's complete rubbish. And I'll say I was very fortunate to find things that excited me and that I found to be things I wanted to dig deeper into. And probably as importantly, and hopefully this resonates for all of you, I found mentors who were encouraging to me and who I wanted to emulate. And I'll say that probably led me to where I am more than, frankly, anything else. If there's anything else that I could tell my 18-year-old self to do better, there is so much to find exciting in life. And I'd say just jump into it. And don't be held back by the boundaries of these identities that we give ourselves. For me, the most exciting things that I do are not only the surgery, but what I get to do with Cancer Care Ontario as an administrator, what I do for the Center of Ethics as a philosopher, the time that I spend with students, not only in neurosurgery, but in multiple other fields. And it's, for me, that richness of diversity that really means a lot. And I'd say don't fit to what it is that someone tells you should fit to. Just do what it is and push forward with what it is that gets you going.
Fantastic. Thank you so much, Dr. Das. And let's see, who has the next unfortunate task of following that up? That was absolutely fantastic. Thank you, Sunit. Should we go to Dr. Catherine Hume?
Thanks so much. I feel like the panel may have been somehow, it was artificially rigged to have two people working in artificial intelligence and neurosurgery who have literature backgrounds and philosophy backgrounds, but it was really interesting listening to Dr. Das because my experience isn't dissimilar. So today, what do I do? So I lead a group at RBC, the Royal Bank of Canada, called LSCE. We are a machine learning research group, and I'd say I spend my time really trying to take care of two things. The one is to make sure that my group is relevant for the bank. So, we're there to help solve problems in financial services, help make sure that Canadian citizens have opportunities to improve their financial well-being thanks to the patterns and insights that we can find in data at the bank. And then the second is to help my group contribute to the future, contribute to helping solving open problems in artificial intelligence research, and in a way that's really unique to what the opportunities that we have at the bank. So we're really working on thinking about the problems that matter and that we can uniquely solve because of the access to the data that we have and the problems that we face. And big on our minds today are the difference between correlation and causation, which is a big topic in both the life sciences, which I know nearly nothing about. So I'm really excited to be on the panel today, as well as many other domains like economics and thinking about the economy. How did I end up here? So I guess for me, the poison pill in undergrad was Paris. I started off I'd always been interested in both humanities and sciences and math. And I started off as a theoretical math major at the University of Chicago. I'm from the States originally, and I loved it. I took a couple of courses in organic chemistry, wasn't really considering pre-med, but I really liked the puzzles of OChem and was very quickly sort of ushered out because I was a klutz in the lab and I was like, man, this isn't for me. So I just sort of stayed in the realm of, sets and groups and ideas. And then I went to Paris and I was like, man, I really like just thinking about literature, philosophy, and film. So I was considering doing a PhD in philosophy, analytic philosophy, which is a passion of mine, and symbolic systems, but was attracted to comparative literature because of the ability to study multiple languages, understand the different cultures, and sort of play my cards as a contemporary Renaissance woman who spent most of my time thinking about Isaac Newton and Leibniz and dead white guys in the 17th century. And I afterwards decided that, going down the path of becoming a professor who knows a lot about 18th century philosophy and epistemology, not a lot of jobs for people who know that, have that knowledge set. So I did my PhD out at Stanford and was immersed in the tech community and was really interested by emerging trends in language analysis and natural language processing, which is a subfield of AI, namely from the humanistic perspective that these tools that I was seeing didn't consider language like language. They considered it like statistics. And that was odd for me because I spent a lot of time thinking about semantics and syntax and what makes language work for humans exchanging meaning with one another. So that sort of inspired me to go into AI, and I opened up, brushed off my math skills and ended up in the position that I'm in today. And I think if I look back at myself at 18, along this path and sort of switching domains, it wasn't easy. I'd say I had a hard time making choices, and there was a lot of anxiety along the way. And so, akin to what Dr. Das said, I think I would have a little bit more confidence and not worry so much about the future. Just sort of trust that the world's changing quickly, and you can't really plan for 5 years, 10 years out like you could in the past. And so, it's really worthwhile to pursue your interests and sort of trust that the universe is big enough to find a home someday. So that's my take, not dissimilar from what we heard before.
That's terrific. Thank you. And Dr. Chaudhary, last but not least, you've got a different perspective on things. And you're in this organization that is quite frankly incredible, that thinks about AI in so many different ways. So we'd love to hear your thoughts.
Yeah, thank you. And those are two tough acts to follow, but I'll try. So I work at at CFAR. So it's a global not-for-profit organization, and CFAR has been around since the early 1980s. And so it is a really cool organization. It has it's been investing in AI since it started. So even before it was cool, it was a strategic program that CFAR provided funding for and provided support for. The program's gone through different names throughout the years, but it is responsible for recruiting top talent to Canada, including Geoffrey Hinton, so one of the founding fathers, pioneers of AI. And it was on that success that the federal government awarded CFAR $125 million in 2017 to run a pan-Canadian AI strategy. So one of the first AI strategies in the world. And this was to really recruit and retain faculty, AI faculty in Canada. So we have so much talent. We have so much research excellence in Canada, but what was happening was we were losing that talent to other countries, to Silicon Valley. So the purpose was to really provide support and funding for the great talent to study in Canada and stay in Canada. So my day-to-day is to really manage that whole program. So our bread and butter is really something called the Canada CFAR AI Chairs Program. And that program, we work with 3 national AI institutes to support AI faculty across Canada, Amy, Mila, and the Vector Institute. And so I get to see all kinds of cool projects come through. I get to see different AI projects at different stages of the pipeline. I get to meet some of the leading pioneers that I mentioned. So it's a cool job day in, day out. So how did I end up here? So I did my undergraduate degree at Dalhousie University in neuroscience, and all I knew was that I just wanted to keep studying neuroscience. That was it. So I graduated and I thought, but I don't want to be a PI. I want to do something at the intersection of science and business. So I thought I would do a master's and then an MBA. So I set off to U of T. I had a really great supervisor and the project was going really well. And he said, why don't you just transfer into the PhD program? You'll have so much more autonomy, when you graduate. So I went through with the PhD. It was great. Lots of opportunities. Got to meet lots of interesting people. Published papers. Graduated, and was like, oh, I have no job. I wasn't really, thinking really actively. I just had a really good time pursuing my research project, but hadn't really been actively thinking about what I wanted to do after. So I networked with people who had PhD in their titles at the hospital I was doing my degree in, but weren't PIs. And the feedback that I was getting was, good job, you finished school, but you don't have any actual work experience, so you'll need to acquire that. So I applied for an internship at the Ontario Brain Institute, and ever since then have been in program management and research administration roles. And it was through one of those roles where we ran a panel on AI. I got to meet Dr. Yoshua Bengio, Dr. Joel Pino. So those are really, let's say, big people in AI. They do really, really interesting research. It was a panel on ethics in AI, and I was hooked. I was like, I want to work in that field. I want to be where those people are. And so as soon as I saw a job at CFAR that did exactly that, that's how I ended up in this role.
That's fantastic. Thank you. So really kind of interesting stories here, right? So for those of you who are interested in this space and are thinking, all right, first of all, that's great. We've got a neurosurgeon, we've got somebody in comparative literature, we've got another person who was in basic science and now is at CFAR doing a lot of really neat innovative AI stuff. How do I get in on it? I think we have to step back and say, what the heck is it, first of all? Because a lot of us have these misconceptions around what artificial intelligence is or is not. And so I'm going to now pick on Dr. Catherine Hume. How would you explain AI to a 12-year-old? And if you put it in simple terms and then just let people know, where do they go to learn more about it? If you can comment on those things, that'd be great.
So hard to do for a 12-year-old, but maybe for how about a 17-year-old? Because I think it helps once you've gone through your first class, you know what a function is, right? So that it helps to give a good intuition. So it's a super hard question to ask. It was mentioned earlier on that AI has been around for a really long time, but it's sort of had a resurgence over the past 5 to 10 years. And throughout its history, there's been different underlying technologies that come under the overall umbrella of what's called artificial intelligence. There's sort of one ambition that is, can we replicate the kind of intelligence that we see in humans using systems of some sort? And throughout that journey, over the last recent years, the latest flavor has focused on machine learning, which is basically an ability to build approximations of functions on large data sets at scale. And so when we think about this, you can start off with, y equals mx plus b. You got a line, you got a data set, and you have this line, and you use it to sort of more or less find a trend within it. But what's happening in AI is that we can take a function of any degree of difficulty. So not just the straight line, but curving and twisting, and not in the 3 dimensions that we live in and perceive, but imagine, millions of dimensions. There's some models that are being built now where they have up to 175, I can't remember if it's billion or trillion in Google's recent work parameters. So these are super complex mathematical models that can take data and do things like classify objects and images. So one of the popular use cases in the life sciences is if you take an X-ray of somebody's chest or somebody's brain, and you could take a large training data set that has past examples of, let's say, a brain that has cancer in it and a brain that doesn't. And the system can learn to build one of these mathematical functions that does a good job separating, yep, there's a tumor, nope, there's not a tumor. So that those classification tasks are quite common. There's other AI systems that are really good at achieving a goal. So some of you may have heard of a term called reinforcement learning. So this is used for games like playing chess or playing Go. And there you'll sort of state, all right, here's my end thing I'd like to optimize or a goal I'd like to achieve. And what the AI systems do is they use trial and error. They try something, they try an action, and then they sort of get some feedback, right, on whether or not that action helped them achieve their goal or optimize their task. And they try this again and again and again, going through many, many cycles until they sort of learn the best way. So those are the 2, I'd say, really common use cases of AI. I'm not sure, is that a 12-year-old? Hopefully that's like the 17-year-old description.
That's fantastic. No, that's incredibly helpful. Are there places where you would recommend people could go and learn more about AI, a place that's accessible? There's lots of online stuff, for example.
Yeah, I actually think so. There's a Coursera course by Andrew Ng. Andrew Ng is a sort of well-known professor and entrepreneur in machine learning. And he's got a great, just sort of introductory concepts. And as you go through it, you'll learn, what classification means, what regression means, if you've ever heard of that term. And alongside it, there's also some coding tasks. So the computer language often used for machine learning is called Python. So I'd say also, if you're considering what should I study, what language might I go into, that's sort of the lingua franca these days. If you're interested in reinforcement learning, that 3rd category that I mentioned, there's a book by a professor called Richard Sutton. Nabila mentioned the AMI, one of the research institutes in Canada. And Richard Sutton leads that group, and he's sort of the godfather of RL. That's a really great place to start too. For deep learning, there's a book by a man named Michael Nielsen online that's sort of an intro to deep learning, a really great conceptual start to get you going.
That's fantastic, because we get questions like that all the time. I want to learn more. Where do I go? So some really good nuggets here by Dr. Hume for those who are really interested in learning a bit more. I also want to say that the center that we have at University of Toronto, TCARM, is actually curating a whole list of educational materials. So if people are interested, we do have a website that people can go to. That curated list should be up and running in the next few months for those people who are interested in learning more. Just for the panelists, we're going to go to the next section around how will AI be used in health. And I want to preface this a little bit just by giving a couple of case examples. And I'm going to give you a couple of examples just from where I am, because I know the examples well, because we've done them. If you can imagine, this is how AI will impact health. This is what I believe. If you can imagine patients in an internal medicine unit, the statistic there is that roughly 1 out of 12 will either die or go to the ICU. And it's unfortunate, because for many of them, we'll have no idea who they are, and they'll just crash. And typically we have just a few hours to react because they crash so suddenly. And the outcome often is unfortunate. And in retrospect, when we actually look at the cases, we say, we probably could have done something earlier if we had known that they were going to crash. So at our hospital at St. Michael's, if you're an internal medicine patient, this is standard practice. It's not a, do I want to? This is actually what's happening right now. This has been up and running since September of 2020, where all of our internal medicine patients are monitored by machine learning algorithms. So the concept here is every single hour, about 100 or so data points come into the algorithm for each of our internal medicine patients. And you can imagine all the permutations and combinations of that data the algorithm goes through. And every single hour, 24/7, doesn't sleep, it actually categorizes our patients as low, medium, and high risk. And as soon as the patient reaches a high risk threshold, for prediction of is this patient going to die or go to the ICU at least 24 hours in advance, it pages the medical team to go see the patient. So then the medical team then goes and assesses, well, what can we do for this patient? So our preliminary data suggests that we've been able to reduce mortality by at least 20% in this population. The potential for patient benefit, the potential to deploy AI in healthcare is incredible. We're pretty new, I guess, in this space. There's not a lot of this going around. There's a lot of interest. But I want to steer now the discussion to what are these sorts of applications we can see in healthcare? Why should we get excited? But also, really importantly, what are some of the big challenges? So I'm going to hand this over to Dr. Das. What are the biggest challenges in applying AI to health and healthcare, and how do we solve them?
Thanks, Mohammed. So, I think you bring up something really exciting, which is this idea that we may be creating tools that can allow us to do more than we would be able to do otherwise. In other words, we're finding something that could push beyond human limitations. And a lot of the problems really stem from what the consequences are of being able to do that. And also, what do you need to actually get an algorithm to that point? And I'll speak to some of those. So one fundamental issue is privacy, right? All of these tools require access to large amounts of data, and data in actually patient-specific contexts, right? It's not important, or it's not valuable to have data that's not given that founded. And with that comes issues of privacy, and ones that we struggle already, frankly, to answer without bringing something like AI into the question, but that are amplified because of the largesse of what's required for an AI system to do something meaningful. The second issue that I'll speak to or bring up is accountability. So this I find really interesting as a physician. When a patient comes to me and asks me for guidance and asks me for advice, I have conversations with them that are based on my own experience, on what we've learned from medical practice and shared with each other in the literature. But I use those things as tools to help me come up with a plan with the patient. And if we follow through on that plan, I've decided to have accountability for what the outcome will be. If my patient goes to surgery and something untoward happens, the weight of that falls to me, not only personally, but legally and ethically. what will it mean when an AI helps me make that decision? Or let's go further, what will it mean when an AI makes that decision? And I say to a patient, well, this is what we should do because the algorithm has told us this is the right choice. Where's accountability? And do I now still have the same identity with my patient that I did when that decision-making was something that I undertook with her?
Yeah, yes, it's very, very involved, and you're asking really tough questions that I don't think a lot of us have good answers to. I want to go to Dr. Chowdhury and get your perspective on machine learning methods that are increasingly being used in health research. What do you think are the biggest issues in applying machine learning methods in health research? And then I'm going to go over to Dr. Hume to learn, maybe give us some nuggets around what finance has learned. Dr. Chowdhury?
Sorry, my mouse died. So I want to start out by just saying I'm overall optimistic and excited for all of the possibilities that machine learning will bring to health and health research. Definitely, though, there are some considerations in terms of applying machine learning methods to healthcare research. So CFAR actually worked on an AI for Health task force last year, convened a group of key experts to really talk about some of these issues in terms of deployment and access across Canada. So some of the key issues that came up were data and access to data. So I think Dr. Das spoke to it, but data and access to data are large obstacles in terms of applying machine learning methods to research. So you can't train your model without having the data. And this was actually something that was repeated to us again and again by researchers. And then tying into that was governance, infrastructure, and privacy, as also we touched on today. So basically, anonymization and de-identification of data were huge issues as well. So it's not as straight. It seems so simple from the researcher side. If we had, if we had access to this data, we could answer this problem. We could go forward and address this research question. But it's not so simple on the human level, where people are still very uncomfortable with consenting to their data is being in centralized repositories for access to access to researchers. So those are some key issues that I don't think they're solved yet, and there are certainly things that we have to consider, even though this research is AI research is so exciting. And then finally, one issue in terms of applying machine learning methods is also considering bias. So AI algorithms, they can actually reflect some of the worst societal biases that we have, and it actually can affect people in underrepresented groups. So it kind of amplifies the biases that we already have in society. It disproportionately affects groups in certain race, gender, and socioeconomic status groups. And so that's a consideration that we really have to take into account in healthcare research and AI.
That's great. Thank you. So there are quite a few issues as are being highlighted, from data access to privacy issues to biases that we see in data. And also to your point, Dr. Das, around the authority of what do you do when an AI algorithm spits out, and we've actually had to deal with this at our hospital. The AI algorithm says this patient might die in the next 48 hours. And the clinician says, I don't think so. And then the patient dies. Where does the accountability sit? Or vice versa. The algorithm says, no problem. The clinician believes the algorithm and something bad happens to the patient, because the algorithms are not going to be perfect. So it's not simply a matter of, hey, we've got a cool algorithm. Like, these actually affect life and death decisions for a patient. And so the stakes are considerably higher. I want to go to Dr. Hume, because finance in many ways are many steps ahead of healthcare. I mean, again, we use fax machines still, right? So there's a lot of learnings I think we can have from the finance sector, who's had to deal with this I think for a lot longer than we have in healthcare, and we're just starting to see all the potential. Dr. Hume, what can we learn from finance?
Well, there's an interesting thing. One of the, I think the difficulties, as mentioned, is that in some domains, like in Amazon and the big consumer internet companies, you can take a model that's trained in one context and then just sort of really easily apply it to the next. They're called pre-trained models. And here, as you mentioned, right, you actually need the patient data. So there's fewer opportunities for retraining. However, one of the interesting things in ML is that developments in one area can, just on the algorithmic side, so a higher level of abstraction, can translate well to a different context. So examples, sort of kind of started in finance, and then it's sort of migrated over into healthcare. So the algorithms that are used to in cybersecurity to track malware, if you can imagine, there's a piece of bad code. It doesn't evolve like totally randomly. It's not like the bad guy in the latest Batman, that played by Heath Ledger. Like, it's not chaotic. They do have sort of a pattern of evolution, and you can use machine learning to predict sort of the next step so that you can be proactively getting ahead of a potential future attack. So we use those kind of capabilities to help with cybersecurity use cases in finance. But as it happens, that same algorithmic structure is used in research around the genetics of how cancer molecules evolve. So there's some work at the U of T Vector Institute in that. So there's interesting sort of an adaptation in the finance domain then is used to solve really interesting oncogenetic research in the healthcare domain. This wasn't quite coming from finance, but the first use case of a capability called natural language generation was by some researchers at Northwestern around 2009 to write sports articles. So you imagine, there's a baseball game, like the Leafs are playing, and it's pretty structured. Like, how many runs did they hit? Like, what was this guy's batting average? And so you could take that structured data that would basically be in like an Excel spreadsheet and then automatically write sentences that communicate what happened, which is sort of, hate to say it, but some journalism is kind of like that. Really interpretive, like thoughtful journalism isn't like that. And AIs can't do that. But it's really interesting for patient experiences. So I saw some really neat work by a company called Area NLG, where they took this capability to basically have a monitor. If you were monitoring for some sort of vital signs on a patient or even a neonatal use case, you could personalize what's communicated to different stakeholders in a healthcare setting. So the parent could have one narrative, the nurse could have another narrative, and the overseeing physician could have a third narrative, all sort of automatically generated from that same underlying data set. So that's sort of a neat application. This is less in finance, but the other thing that I found interesting in healthcare is I did some work back in the day on robotic surgery. So we're using ML. It's like there's lots besides just AI, but in the narrow use case, it was to do prostate cancer surgery. And honestly, the obstacle to getting the work done for our team was that the data was disgusting. Like we had this video corpus with all of these bloody prostates, and we were like, oh God, like, why do we have to predict what's next? So I think it's really interesting. Often in these applications, the AI will be a small component of a much larger technology investment that includes engineers and engagement with surgeons. Because we need to benefit from that subject matter expertise to help train the algorithms. So it's sort of the flip side. I think accountability is then an issue, and I think we're a long way off before we see these in practice often. But there's some really really interesting stuff happening.
It's really neat, and I kind of like to highlight that this field it's so interesting how there really needs to be this cross-fertilization between disciplines. In fact, one of the algorithms that we were considering, we were borrowing methods from agriculture, because it so happened that plant growth patterns and the time series methods used there were actually quite relevant to one of the clinical problems we were trying to solve. And so I imagine there's lots of cross between finance, physics, agriculture, all these sorts of disciplines. And it's a matter of figuring out what that problem space is in mathematical terms. So this is, again, why I'm really thrilled that we have such a diverse panel. I do want to leave enough time for questions from the audience because we have a few of them. I do kind of want to touch on now the job market, because that's going to be top of mind for a lot of students is, all right, well, what am I going to do when I get out of here? How can I get employed? So let's actually talk a little bit about that. I want to get perspective from Dr. Chaudhry in terms of what you're seeing with respect to healthcare continues to evolve with increasingly complex data and sophisticated methods. So what sorts of jobs do you think would be there for AI-related health research?
Yeah, I think that's a great question. I think Catherine touched on this earlier, where things will change so much within the next 5 to 10 years. It's a little bit hard to predict, but I can only see really growth. And in terms of growth, I want to just say that I know that sometimes that there's this conception out there that, oh, well, AI is going to automate everything. So what do they need radiologists for? And there's all as just as an example. And I think like what will actually end up happening is that AI, we should think of AI as a tool. It's a tool that's going to augment many of the existing jobs and even bring new jobs into creation. So those are two things that I just wanted to highlight in terms of specific jobs. Like I think the sky's the limit. So I think it's just that you have to keep in mind that you have to be adaptable. So you have to be ready to change with the times and change with the technology.
Fair enough. From a more clinical standpoint, Dr. Das, where do you see the opportunities?
We excitingly have our first MD PhD student at UTMS who has decided to do his PhD in a machine learning lab. He's our first one. But I think there's going to be a need for more people who are able to be the bridges between these different worlds. As Dr. Humis said, these are teams that require expertise from multiple different sources. And it's frankly the fact of bringing that expertise together that I think probably makes the possibilities so exciting. So we're going to need people who frankly are able to do that work of translation. That doesn't necessarily mean getting a PhD in machine learning. That may mean understanding what it is to have an algorithm in a language that allows you to communicate as a clinician to the computer scientist or as a developer to the engineer. But I think this sort of crosstalk and that fluency in the different languages of these different worlds is going to be, frankly, critical to next steps.
Oh, that sounds good. Let's go right into the questions from the audience now. There's some really good ones, and I think this maybe flows right into Dr. Das. Maybe I'll point this one to you. With the emergence of AI, have you noticed effects of students choosing to avoid different medical specialties like radiology, pathology, anesthesiology?
Yeah, we've talked a lot about AI as being tools to extend what physicians are able to do. We haven't as much other than Dr. Chaudhry speaking to radiology about AI replacing physicians. And it's a real fear, I think, particularly in fields that are about pattern recognition, where we see perhaps a kind of a nearer translation of AI into actual practice. So fields like dermatology, fields like pathology, fields like radiology, I think there is a concern of threat that they could become obsolete because of machines that can do what they do just as well or more efficiently. We actually canvassed medical students throughout Canada on this question. And it didn't appear to translate into decision-making on the part of students in terms of what field that they would go into, but it is a concern that they articulated over and again. I'm optimistic, I think, as Dr. Chaudhry is, that these are going to be changes that modify our identities, not replace them. And I'll speak to the fact that 100 years ago, the medical equivalent of a cardiologist used a little tin that he put on the chest, and specifically put on the chest to listen to the heart. In the 1930s, that was replaced by something we called a stethoscope. In the 1980s, we realized that an ultrasound that we call an echocardiography could do that even better. We still have cardiologists. What they do and how they do what they do has become more refined. And my suspicion is that's what AI will mean for us.
A great response. Absolutely. That sounds good. Now, the next question I'm going to ping over to Dr. Hume. The question is, I wonder what we can learn from finance about handling access to data and protecting clients' privacy. Are there lessons to learn in healthcare to address some of the challenges that the other panelists have raised?
Yeah, it's a great one, and it's a tough question. So I think, there's at the basics, Dr. Mabadi mentioned a couple of times that there's still faxes in healthcare. So there's one sort of baseline approach that is just the first sort of sense of digitization. It could be an opportunity in that all of these issues are on people's minds now. And so it's the crutch that is being on sort of physical paper systems could become an asset in that it's an opportunity to design systems with privacy in mind from day one. And in terms of, some of the techniques that we're using in financial services and that are important. So this is sort of a separate topic, but there's big questions right now around the adoption of the cloud. The Canadian financial services groups tend to be a little bit skittish of putting a lot of our sensitive client data into cloud-based systems. So, for example, payments, anytime we send money from one person to another, these are sort of critical systems that manage the economy, and they're not yet on the cloud. They're on sort of more protected, controlled architectures. In the field of machine learning itself, if you're interested in going down this path, there's actually a couple of research areas related to privacy. One in particular is called differential privacy. So this is where, in machine learning, we care about statistical averages more than we care about particular data points. And it's possible to take a data set and sort of add a little bit of noise, we call, so sort of modify the data slightly so that you still get your insight. You have to trade off a little bit of accuracy. It's not going to be sort of perfect when it comes to that classification of high risk, medium risk, or low risk. But these are really active areas of research in being able to do machine learning while protecting privacy as well. Bias question is a whole nother ballgame. It's something we have to think about a lot, in making decisions like, should somebody get a loan, a mortgage, for what value? And I'm happy to also share, there's lots of good resources on fairness, in particular from a researcher named Moritz Hart. So anything that he's written is a good place to start to think deeply about these questions.
Fantastic. Well, thank you so much. And just one more question I think we have time for. I'm going to direct this one to Dr. Chowdhury. It says, since machine learning requires large data sets to optimize an algorithm to predict a pattern in the data set to make future predictions, and this is their understanding as a neuroscientist in training, how useful is this application in rare diseases, rare brain cancers and such? And maybe I'll just preface this to say, yeah, I think a lot of machine learning algorithms are data hungry. They do require quite a bit of data. And when you talk about rare diseases, your sample size is itty bitty. That being said, there's a lot of push for collaborative research initiatives where we can actually work across not just Canada, but across the world to be able to pull data together so we can learn more from patients. So Dr. Chowdhury, can you tell us a little bit about some of the challenges of how do you get the data and how do you actually make it amenable to these sorts of applications?
Definitely, you've taken my answer, I would say. I think that's a big push from our organization as well, is to really push for that open science, open sharing of data to try and get the collaborations going so that data and large data sets are accessible to those who are studying research questions. So I think you answered that one perfectly. And another thing that I've come across that sort of addresses this question is looking into synthetic data. So just using synthetic data sets to try and answer questions about rare diseases, and using AI to answer questions about actually really any healthcare problems that we just don't have a lot of data for. But it's a really new field. Yes.
That's great. Thank you. I know we're almost at time. I just want to address one other question in the interest of time fairly quickly. There are people who are saying, all right, if I want to get into this, do I have to like math? And the short answer is for a lot of this, yes. But no, really, there are lots of other areas. And for others who say, well, I don't have much experience, I don't want to spend 10 years learning this stuff. Well, this is a lifelong learning thing. So, we got to toughen it out and just actually learn. So there are no shortcuts. Now, that being said, there's lots of phases to AI. There's a whole field around doing the hard math in AI. There's the application of AI. The data space is massive now in terms of how you actually get the data together. But then I would also argue there's a whole emerging space on AI implementation, where it's not so much on the math side, but on how do you actually implement and deploy AI into, let's say, healthcare practice or into any sort of practice. So there's lots of options and opportunities for people to get engaged in this space. Now, again, I apologize. I know we're at time. This has been a fantastic opportunity to get some incredible panelists here. And I sincerely want to thank them because I know they're incredibly busy and you're incredibly talented. So I really want to thank you for being so gracious and giving the students some of your time and wisdom so that we can learn and grow and hopefully fuel this field of AI in healthcare. So thank you to the panelists. Sincere thank you. And thank you to the audience. And I think we're at time. So thank you, everyone.